Okay, so on Wednesday, we have an exercise and we try to practice for this exercise, and the material is water. Okay, and what is the purpose for this exercise? The purpose for this exercise would like to tell you the material volume should be large enough, and then we can have the physical properties consistent, right? If the volume is not enough, the physical properties will change depending on you how large volume is captured. Okay, so the second exercise, we will focus on the material for the air. As we know, what is the air? So if you consider the material is air, for me, I know that the air has the 80% the N2, right? And we most have the 20% O2. So based on this roughly component compositions for the airs, we can compute the molar mass. So the molar mass for the airs, we actually know the N2 is the 28, and then multiply the 80%. So the next we should plus the O2. So the O2 is the 32, but we only have the 20% component. Okay, so you can compute the values using your calculator here. So the answers for the molar mass of the air is the 28.8. So the unit here is the G per mole. And usually we say that we will convert to the kg unit. So here is the 28.8, but we have multiplied 10 minus 3 and convert the G to kg unit. Okay, so we have the molar mass, and if we have the density of the air, so we should have the density of the air. And again, if you take a look, we focus on the conditions. The room conditions is environment like here. So usually the room conditions air density is equal to around 1.23, and the unit here is the kilograms per meter cubic. Okay, maybe you didn't know the density of the airs, but here I just tell you the density of the air. Okay, and for these problems, the necessary information is the how large mole we have for the air, right? So as you remind you, there is the molecules numbers. So we have the 1 million molecular number, so we can compute the mole. The mole is equal to the 1 million divided the avocat numbers here. So this is a 6.02, and multiply the 1023 powers. Again, so we can compute the moles for the airs. So again use your calculators, and then you can compute the answers. It's around the 1.661 and multiply the 10 minus 18. So this is our mole. Okay? So you have the mole and you have the molar mass. So you can compute the whole weight of the errors. So as we know that if the weight or the mass m for the errors is equal to the molar mass multiply the mole. So you directly apply the number here is 28.8 10 minus 3 multiply the 1.661 and the 10 minus 18, and you know the mass for the errors. So I use my calculator and multiply the 28.8 and multiply the 10 minus 3 powers. So the answers here is around 4.784 and 10 minus 20. 10 minus 20. So the unit here is kilograms. So actually we know the density I have highlighted here, and we can compute the volumes of the errors. So the mass divided the density, so we have the volumes. Okay, so put the number here, the 4.784, 10 minus 20 divided the 1.323. Okay, so divided the 1.23, and the answer here is 3.89. It's roughly, and the 10 minus 20 powers. Okay, so the unit here is the cubic meters. So there is a simple way. We just take a volume of the cubic root, and then we can have the final answers. So we take out the cubic root, and the answer around the 3.38, maybe 3.39, and the 10 minus 7 meters. Okay, so the answer showing here is quite close. I'm showing on the right upper corners. Okay, so this is a very simple exercise, because we know if you satisfy the continuum assumptions, so that any material can be cut to be smaller. But you cannot always cut the material. You should satisfy some ideas, the volume should be larger enough. If you cut the material become very smaller, the physical property will change. It's not correct, and that didn't make sense, right? So this is a simple idea. If we would like to have the density of the water or air, how large volume we need to capture, and then we can have the true answer for the density. OK， 所以这个案例就是想告诉我们说，你物体的连续性是 我们可以接受的，所以你可以一直去切，把它切成无限的小。可是当你把它切太小的时候，你量出来的物理量就会不可信。所以其实实际上你有一个极限，你们也不能切得太小。那个极限就是我们可以去计算的，就是说至少要多大才可以让你去算到水的密度是合理的。Okay, so but some ideas how big and then we think is enough. So usually previous slide just showed the theoretical volumes, but it's too smaller. So usually we will multiply the 100 times. So as you see, the number showing here is totally the same compared with the previous slide. But we will multiply the 100 times. And this is our final answers. Okay? Because the theoretical value sometimes may be not accuracy. So if you multiply it 100 times, I can make sure this is really satisfy what we want. Okay? So I just write down some importance. This is our final answers. Okay, so move to the next slide showing here. I always emphasize the unit is quite important for our class. So you need to know the certain conversion factors. As you can see, I highlight some important things. The 1ft is equal to 0.3048 meters. And the 1ft is equal to 12 inch. Okay, you need to, the table show many conversions, but you just capture some important informations, and you can convert by yourself. So if you are so smart and you can remember everything showing here, but sometimes maybe you have some troubles, so you will forget some things. So I suggest you just remember some importance, like the right angle I put in slide. And you know that for the mass, 1 kilogram is equal to 2.205 pounds. Okay, and if you compute by your calculators, and you can understand that 1 pound mass is equal to 0.454 kilograms. Okay, this is a very important information. When you do the when you go to the gym, do the exercise for the weighting trainings, and this is very important. Okay, 所以我们去健身房的时候，常常发现有人感觉自我良好，他就以为他卧推可以推10公斤，结果人家上面写的是10磅。那显然这个就叫自我感觉良好嘛，因为怎么样，1磅等于0.454公斤嘛，那所以他会觉得他做10公斤，可是根本就不是嘛，其实连5公斤都不到这样子。Okay, so this is very important. You need to directly to know the conversion factors between two units. Okay, and sometimes for me, most important because this class we are talking about mechanics. As I mentioned, the mechanics is some motions associated with the force. So the unit of the force is quite important for our class. Okay, as I show in the bottom, in the table bottoms, you see the one pound force. What is the 1 pound force? The 1 pound force indicates the 1 pound mass multiply 1 g. And we know that the g is the gravity constant, right? And the gravity constants, usually we know that is a 1 bomb mass multiplied the 9.81 meter per second, right? But the unit is not consistent because totally we have the 2 unit standard. The first one is we call that the SI. SI is 公制, right? Standard unit. And another is the English unit. We say that the 英制. So we have 2 standard units. It's 公制 and 英制. Okay, so right now I write down the number showing here. The unit is not consistent, so I need to convert to the standard unit to English unit. Okay, so as you can see, so we know that the 1 ft is equal to 0.3048 meters. So I can convert the meters. I can convert the meter showing here, right, to ft. So actually, how to do that? I know the 1 bomb force. I keep it, and I keep the number 9.81, but the meter should be converted to the ft here. So I need to divide it the 0.3048. And the meter will change to the ft and the per seconds. And the per second. Sorry, here I forgot to some square seconds here. Okay, so if you use your calculator to compute the number showing here, so the 9.81 divided 0.3048. So my computer showing the number is around 32.18. Okay, so a little bit difference compared in here, but no matters. It just maybe some people use the different gravity constants number. Usually you will use the 9.8. Okay. And here I use the 9.81. So there are some a little bit difference. It's no matter for in our class. So for my opinion and the suggestions is you don't remember everything. You only need to remember some basic unit for the length, ft, inch, and the meters, the relationship between them. And the second you need to remember is the mass and the kilogram bomb. Okay? And so what is the slug? Here you can see the mass, but there is a slug. So what is the slug? The 1 slug is equal to 32, sorry, there's no space. So the 1 slug is equal to the 32.18 bomb mass. Okay, so the physical meaning for the 1 slug is indicate you have the 1 bomb force, and the 1 bomb force have the 1 ft accelerations, 1 ft per second square accelerations. And then here is the 1 slug. Okay, here is the 1 slug. So 1 slug acting with the 1 ft per second square accelerations is equal to 1 bomb force. So if you compare these equations and here, and you can see the number shown here should be equal to 1 slug, right? And the unit is here. the unit 1 bomb mass and the conversion factor here. Okay, so 这里的意思就是 one 这个一个 slug 很容易被忽略掉，因为我们很少用这个单位字哦，但是它是英制的重量的单位，英制质量的单位。那所以你在转换的过程中，其实一个 slug 的定义就是某一个质量，它作用一个 ft 每秒平方的加速度，它会等于1个磅力。那这时候这个一个 slug 就会等于32磅质量，这样子，大概等于32磅点118的这个质量。Okay, so you need to understand how to convert the unit by yourself, and I always emphasize the unit quite important for our class. So you need to keep in mind if you will forget something, and you can try to practice by yourself and based on this table when you go home, and you can try. Okay, so I just highlight some important units. Okay, so the next this is our second exercise, and you can practice now. So as you can see, I provided a certain definition for the gamma. Gamma usually we call that the specific weight. 这是单位重。And then specific weight is equal to the density multiplied G. G is the gravity constants. So here I show the water, the liquid water. And what is the liquid water? The gamma for the liquid water. So the gamma, I use the gamma W, it means the liquid water's specific weight is equal to the density, water density multiplied the G, right? And it's quite simple because we know that in the room conditions, the density is 1,000. 1,000 kilograms per meter cubic. And then the G is the 9.81, and the unit is the meter per second square. Okay, but you notice that here the unit for the gamma is Newton per cubic meters. The Newton per cubic meter. So as we know that the unit for the Newton, the 1 Newton is equal to 1 kilogram, right? The 1 kilograms. And we have the 1 meter per second square accelerations. Okay, so you know the Newton unit is equal to the kg and the n per second square. Okay, so we need to have the unit showing here. As you compare, there is the kg and there is the meter per second per second squares. So finally you know that the R, the gamma W is equal to the 9810, and the unit is newtons, and there is a meter cubic. Okay, but for our questions, how can we convert the SI unit to the English unit? Okay, 公制 to 英制. Okay, so we need to know 1 bomb force is equal to what's newtons, right? 1 bomb force is equal to what's the Newton number here. So if you forgot, and you can go back to see the table showing here, right? It's equal to the 4.448 newtons. 4.448 newtons. So we know that the 4.448 newton. And then we know the 1 Ft is equal to 0.3048 meter, right? So all of the units showing standard unit 公制, you can based on the two relationship to convert to 英制单位. Okay, so you know that. So we know the 9810 should be divided the 4.448, and then the unit right now will convert to the bound force, right? The bound force, because we know the one bound force is equal to 4.448 newton. So I divided the 4.448 newton can be converted to the bound force, right? And then the seconds, there is a meters cubic. There is a meter cubic. Also, we need to convert the meter cubic to the Ft cubic. To the Ft cubic. So here we should multiply the 0.3048 cubic power, right? And the unit will be converted to the Ft cubic unit. Okay, so you can using your computer to compute the values. So the 9.9810 divides the 4.448 and multiply 0.3048 and cubic, okay? For me, my calculator show the number is 62.45. And the unit right now is the bound force divided Ft cubic. Okay. So for the first time, we can derive and convert the unit by ourselves, right? But in the future, you may keep in mind the number, and then you don't need to recalculate again. Okay, so this is a very important numbers you need to keep in mind. The gamma W for the SI unit is equal to 9800 Newton per meter cubic. But you convert the unit to English unit, you will have the 62.4 bound force per Ft cubic. Okay, so in the future, you need to keep in mind, and you can directly apply the gamma W. Okay, so the next slide, I will show some literacy for the equations. For this one, it's quite famous, so I didn't introduce again. But any two particles with the mass will have the attractive force between each others. So we call that the Newton's law. So that's why we will have the gravity constants, because we know the universal gravity constant capital G, and we know the how mass of the Earth, and then we know the radius of the Earth. So we can compute it's equal to the 9.81 meter per second square. So the next important equation for the gas. We call that the ideal gas law. So as I mentioned, the ideal gas law, the basic assumption is there is no interaction force between two particles. And then you can satisfy the ideal gas law assumptions. So some condition does not satisfy. So as I showing here, the first one is if your condition very cold and under very high pressures, you cannot use the ideal gas law. So the reason why we can figure out, because if they are very cold and has the compression force. The compression force will let the two particles become close. If the two particles close, there should have some interaction force. So we can't, under the high pressure conditions, we can't apply the ideal gas law. Okay, so this is, you need to take the notice that for the first one condition, we cannot use the ideal gas law. The second condition, if the environment not homogeneous gas, if the environment there are two phases, the liquid and the gas, as we know, the two different material will have some interactions. Okay, so we cannot also apply the ideal gas law. And the interaction between two different phases, like the gas and the liquid, or the gas and the body, we call that is the viscosity. 我们上一次一直在讲粘滞力。So you have the viscosity force, so that means it is one kind of the interaction force. So you cannot apply the ideal gas law. Okay? And also the final one is very hot. Because the temperature increase will provide the kinematic energy. And you have the kinematic energy, so the particle can randomly moving. And the randomly moving will provide high opportunities to particle collision together, right? So if the two particles collide together, there are some interaction force. So we cannot say no interaction force between two particles. So we cannot apply the ideal gas law for these conditions. OK, 所以不是太冷就是太热，不然就是太高压，不然就是根本不是一个均质的气体，是有其他相位存在，那我们就不能用 ideal gas law. Okay, so if you can satisfy the ideal gas law assumptions, and sometimes the gas we are focused on showing the tables. So the different elements we will have the different molar mass. Okay, so actually the molar mass you can directly check from the chemistry table, right? And there are the chemistry table lists all of the elements, the molar mass. Okay, so most are important gas are showing here. Like the nitrogen is 14, and the oxygens is we use the 16, and the hydrogens and the heliums and the dry airs. Okay, so you can check by yourself. And I emphasize that the molar mass divided by the mass divided the mole. Okay, so you need to keep it in mind. So the table shows all of the formula for the gas law, for the ideal gas law. So this one is the standard one, right? TV is equal to nRT. We usually remember these formulas. So as I mentioned in previous slide, and here the U, what are the U? What are the RU? Ru is the universal gas constant. And the R is specific gas constants. And based on the table, summarize the one formula in here. Okay, in here. So we know that the specific gas constant should be equal to the universal constant divided the molar mass. Okay, and as we know, so I just reorganize the equation. So the universal gas constant should be equal to the specific gas constant multiplied the molar mass. And then the molar mass is equal to the mass divided the mole, right? Divided the mole. So if this is our equation 1, if you put the equation 1 to here, you push the equation 1 to here, so we know that we can rewrite the PV is equal to N multiply the specific gas constants, and there is the M is the mass and divided N, and the T is absolute temperatures. So right now we can cancel out the moles, and the ideal gas law can become the different formulas. So as you see, will become a PV equal to nRT, right? Because the moles cancel out. And then if you move the P and you move the volume to the right hand side, so the N divided the volumes and the RT here. So this item is equal to the gas density. And we will have the different formula showing here. P is equal to rho RT. Okay, so I just reviewed. I think all of the students stay here. You already know all of the formula before, but sometimes we forgot everything. Okay, so the table showing here just remind you some important ideal gas law formulas. So all of the formulas showing here, you should remember. And there are some important units, just also highlighting here. The PAR is the pressure unit. And the PAR unit is the Newton per meter square. Okay, the Newton per meter square. The pressure is the force divided the area. Okay, so you can see the Newton per meter square, and the density unit, everyone know that. And the specific constant, gas constant, the unit is Joule. J is Joule. So what are the Joule? The Joule like the energies, right? The Joule like the energies. So the Joule came from the energy. So as I mentioned, if you have the one force and there are one particle in here, you move the particle with the distance x by this force. So the energy for this problem is the force multiplied the x distance, right? So the unit of the Joule is the Newton force multiply the distance. The distance should be the meters. So the unit of the Joule is the Newton multiplied the meters. Okay, and there's a kg, and the capital K is the absolute temperature unit. Okay, Kelvin. Okay, so something like that, and you can check by yourself. And this is just use the different unit, use the English 音字的 formula. Okay, and if the unit different, so the number also change it. But the previous one is standard what we use. Okay. So we have some practice. So this exercise tell you we have the moles. The mole is equal to 3. Okay, and I tell you the mass is equal to 66 grams. And what is the specific gas constant R for this gas? As I mentioned, the specific gas constant is equal to universal constant divided the molar mass, right? And we know that the molar mass is equal to the mass divided the N. So we know the answer here 66 grams divided the 3 moles. So the answer is equal to the 22 G per moles. Okay, and then you can put the number in here. So the RU, I already tell you the RU in here. Okay， 基本上我们不给 RU 就没有人写出这个题目的答案，因为我们不太会背 RU。不过这个不是我们这个课要去刁难你，所以这种东西我们都会给。Okay, so we have the universal gas constants in the uppers. So the 4462, and divided the 20. Divided the 20, but here has some a view mistake here, because the unit, as you see, the unit here is K, but in here we should have the kg unit, not the G unit. Okay, so the 20 in here, we should multiply the 10 minus 3 to convert the G to kg. Okay, to convert the G to kg. And then we can compute the final answers. So use your calculator to compute, to check the answer together. So for my calculator, show the number around the 378, and the unit is similar to the universal. It's the same as the universal gas constant, Joule per mole, multiply the Kelvin. Okay, absolute temperature unit. Okay, so what I use the red color here, because usually we will forget. We will directly to compute the specific gas constant by the 22, but the unit is not consistent. So you need to have additional minus 3 power 10, and the number, the answer is correct. Okay, 所以其实我们在算东西的时候都不是很困难，但是只要单位错了，答案就会错得很离谱。OK， 所以我们这堂课的第一个章节就是要告诉大家一些用简单的观念，可是我们要一直去复习一些单位的转换，那就对我们来讲就会比较重要一点。有什么问题呢？哪一个地方？
就是最后答案的那个单位。
应
该是焦耳除以公斤乘以一个那个离莫尔消掉。
哦，你说这个对，就还会有一个 K 啦，对。
这个 K 离 你写墨的声音，但是它应该就是因为原本 RUA 有那个墨，
这里对会跟这个
会消掉，对，
会有一个 kg， 对，所以这个我做一下笔记，把这个消掉。没错，就是这里，因为我是除 kg 嘛，对不对？墨本来就会互相消掉。OK， 好，这个同学你这样就很好了，你就不用讲那么小声，你大声一点，把我再录进来就好了。这个就很好，因为我们常常都会有没有看清楚。OK， 所以大致上大家要特别去相信，一定不是相信我嘛，要特别去相信右上角写出来的答案。OK， 好，那我们先休息一下好不好？我们等一下回来，我看我这个剩几页了。哦，没剩几页，所以我们等一下可能应该还是会提早下课，然后我就会用卡户跟大家讲说，那我们下一次考试的这个重点可能是什么？好，我们就休息，一样休息10分钟 ，OK。